Good morning, students. This is Professor Golding. I have another short video for you this morning. I want to wrap up our study of and review of encoding integers in binary. And so this will be the last of this mini-series. I have many other things I think that we're going to do over the next several weeks in terms of review as well. So let's continue on. We have the same two binary streams that we've been looking at over the last few days. Except now somebody tells us that these have been encoded in 2's complement. So now the question is, what are the values of those binary integers? And the answer is, well, we first want to ask ourselves the usual question, are they positive or negative? And the answer is the same as it has been before with 1's complement, and that is that the leading 0 there on the left indicates that we have a negative number, and then the bottom binary stream, which has a leading 1 on the left, would indicate that that's a negative number. So one of them is positive, one of them is negative, just like we had when we were doing 1's complement. Looks like I need to change this little notation over here and fix that up from the last time because it was identical. And so now the answer is, let's evaluate them. And again, we evaluate the top number, the one that had a leftmost 0, just by using the place values as usual. And we notice that we come up with the same number that we've come up with over the last several days, and that's 76. So that's the first thing I want you to remember, is that when there's a leading 0, all of the interpretations are identical. Whether it's signed, unsigned, 1's complement or 2's complement, the magnitude of the binary stream is always the same number, and in this case, it's 76. All week long, we've seen this positive integer represented as 76. But again, now we have to look at the bottom binary stream and ask ourselves, well, what about that? And then again, we find there's going to be a little bit of difference. In the binary stream for 2's complement, we also need a little bit of an algorithm, but it's just a bit different from what we saw last time on 1's complement. We take the binary stream, which we see right about here, and first, like we did on 1's complement, we invert the bits. So we have them inverted here, and then we do one other thing before we evaluate, and that is that we add 1. So I've added a binary integer of 1 here, and now I add it to my original value, which then shows up down here very simply. And then I can evaluate it as I've done before. Well, this is kind of a pest showed up here. And we can evaluate, as I've done before, 64, 8, 2, and then I have this additional 1 down here that I can add. So my total is now what? 64 plus 10, 74 plus 1 is 75. Now that's just telling me the magnitude. It's not telling me the answer. The answer is that when I've done this, I put a minus sign in front of the magnitude, and my answer is actually minus 75. That is the most common mistake that's made, is people often will get the evaluation correct, but then they will forget to put in that minus sign at the end. So I don't want you to forget that, so we can get some real perfect scores if this shows up on the final exam. So let's go back to the beginning for just a moment. And I want you to say to yourself, okay, when I see a leftmost 0, I'm not going to invert when I do 1's or 2's complement. That's also a common mistake. I'm just going to evaluate it, just like a normal binary place value integer, and find out the positive number. It's if you're doing 2's complement and 1's complement, and you have a leftmost 1, that is when you invert. And then you do the inversion, and then you do the evaluation. In 1's complement, you just invert and then evaluate. In 2's complement, you invert, add 1, and then evaluate. Thank you for joining me this morning, and I hope you're making good progress on your research papers this week. Bye now.